Okay, so today is our last class. The idea is to talk a little bit about AI and where this comes from, what are the capabilities and the shortcomings of the artificial intelligence models that we have today, what is the prediction of what can happen in the future, and things like that. So the first part of the talk, we will talk about a little bit of history of artificial intelligence and how ChatGPT works. What is ChatGPT? That's probably the most used large language model that we have access to. And then I will talk a little bit about ChatGPT in scientific writing. This came from this quite long paper that is available for free through ResearchGate. I will give the reference here. And where the authors did some tests in practice, taking ChatGPT, taking a paper, demanding something, and then looking at what ChatGPT did. And since they were the authors of the papers, they know very well the subject, so they could say, okay, it did well, it didn't do well, and so on. So we will go through some points in the second part of the talk. So, waves of artificial intelligence. So the idea of artificial intelligence, it evolves through several waves because we had peaks and valleys, and these valleys are called winters of artificial intelligence, moments where I heard from a professor in the field that knows very well that people who have mentioned that we're doing some research in artificial intelligence, they are viewed as scammers or people that were doing something not right. Because the idea was, this field gives the, say that will do lots of things and so far has delivered not much. So that they call the winters of artificial intelligence, 2 winters, and then it came, and I believe this time it came to stay. Of course, the technologies will come and will disappear, but there will be always something new replacing, etc. So I believe you and your sons and your grandsons, they will all use artificial intelligence in some sense. But the idea was really that how to make machines intelligent. And the birth of artificial intelligence was really with the Turing test in 1950. So we are talking about almost 80 years. This is a lot. So that's why we have to keep that in mind. All these paths of artificial intelligence, it's nothing that came in 2023 with ChatGPT. It came from long, long ago. So the idea of Turing paper was to propose a test to check if the machine was intelligent or not. So he proposed this imitation game, known today as Turing test, and there is a movie, I think it was in 2014, probably, about the Alan Turing, which I suggest you strongly to watch because it's a very nice movie. And the idea is to define the intelligence, machine intelligence, with a focus on observational behavior. So what was the idea? If you have a computer that you can talk to the computer and you do not figure out that this is a computer that's talking, then it's intelligent. And we see every day around us these chatbots and the idea of, for example, robots companion, and people using ChatGPT to make therapy. Basically that, right? We are reaching a level that maybe at some point you will not be sure if what's on the other side is an AI or is a human being. The term artificial intelligence came in a summer research project in 1956, and the guy was this guy, John McCarthy. This is the date considered as the birth of the AI, and this term was coined by McCarthy in this event, and they had a very ambitious agenda focused on symbolic reasoning, problem solving, and natural language processing. So this is an important point because what we are doing now with ChatGPT is exactly that, natural language processing. We're processing our language. And this was already in the academia, no? In 1956. So 70 years ago. It's a lot, no? At that time, the intelligence was used representing symbols and logic patterns. Programs manipulated formal rules, so you have rules that the program should follow and at the end give a result, in the sense that we have the programs of today. So if you input the same thing, at the end you have the same answer, completely different than ChatGPT. If each of you asks a question to ChatGPT, probably it will give an answer different to everyone. So quite different. And as an example, theorem provers, planning systems. One that I add is, for example, the chess player, right? This is an interesting thing. Games, from the beginning, they have somehow artificial intelligence. From the beginning. You remember how difficult it was to, if you had a game, you're playing a game, and I played games since the 1998, 2000s. If you put in a like advanced mode, it was difficult to win, right? And chess play was one example. And I remember vividly, I was in the States, it was 2001, when Kasparov, the chess player, quit trying to win IBM's processor, right? So IBM launched the new processor, Blue something, Blue Dream, something like that. And after that, Kasparov couldn't win IBM's computer no longer. But at this time, it was just formal rules. Lisp, it was a program language that was developed by this researcher who coined the term artificial intelligence, and I was using for programming AI research. And there was a software developed at MIT, ELIZA, which was a language processing program based on the early natural language processing. So this software, it was the idea was really to have information from physicians and a code merged together, so specialists, and you make up a software that will distribute to the hospitals. And when someone comes with some symptoms, the person who is doing the evaluation will type in the symptoms, and the program will process and give quickly what is probably the disease or something like that. What is the diagnostics, right? So this is the first wave of AI. Here's the winter and Turing test, the concept of artificial intelligence, robots from General Motors, the ELIZA program that was able to hold conversation with humans, and another electronic person from Stanford, and it came the winter. So everything cooled down for a while after 66. And then came the second wave, what they called expert systems. So the idea was to use knowledge representation. And from that time, we are talking about the 70s. People realized that research, artificial intelligence could not be just about logic. It had to process vast amounts of knowledge about the world. So you see the seed of ChatGPT of collecting all the data was already there. When I was preparing this talk, gathering all this information, I realized that the movie Matrix, now it came up a question because you see so many elements of what we see nowadays with artificial intelligence that before preparing this class, I was thinking, oh, these brothers, they were really forward in the future, thinking years ahead. But now I changed my mind. I think they had actually very good experts in the field with ideas that has been there from the beginning. The problem is they didn't have the tools, as we will see, the tools, the data, the computers to implement. But the ideas, they were already there. Because now, for example, we live in the era of the agents. So what is this era? And this library was actually programmed by a Brazilian that is working at Silicon Valley now, making millions. And the idea is to create small programs, one can say, called agents, and each agent is specialized in something. So, for example, if you want, nowadays it's very common that you see videos that, for example, you make a video speaking in English, and then you give it to an artificial intelligence, it makes you speak in French. And you have the subtitles in French, you have the audio in French, you have your mouth moving more or less like you're speaking French. So the idea is you have one agent that's specialized in each task, one translating the language, another making the caption, another moving your mouth. So you split up the tasks, each agent will do something, and at the end you have everything completed. Right? Good. If you are a fan of a Matrix as I am, when you speak about agent, you just think about Agent Smith, and all the agents in the movie, right? They were fighting against Neo and etc. So, as I said, now I believe all these concepts that are embedded in the movie, they were already there. They just couldn't realize, couldn't make it work at that time. So expert systems, the idea was to encapsulate the knowledge of humans and then use specific domains to make decisions. So there was one called MYCIN in 74 for diagnosis of blood infections, and another called Doctoral for chemical structure elucidation. So there's two examples. So the idea was you pack with rules coming from experts, and you ask the software to process and come up with new concepts. So that was the idea at that time. But the seed of processing vast amounts of knowledge was already there in the 70s. So this is one example of this MYCIN architecture. So here you have an expert. There is the physician. You have a large database of information on patient. You have rules with tables, lists, etc. And then the expert feeds up with all of that. The physician is on the top with a consultation system. So he has a computer, a patient, he writes things, and at the end, oh, here's the diagnosis based on this large amount of data. And this is really interesting when we put together now with the idea of ChatGPT, Because if you think about knowledge, right, when you are in a situation like that, why ChatGPT, like why artificial intelligence can be really a game changer? Because no expert can dominate the entire database of diseases and things like that, right? I have one example of a daughter of one of my professors. She went to some kind of walk in caverns and things like that, and she came up sick. And she came home. It was some in a different part of the country, and she started to get sick. And then the doctors in the place where she was, they couldn't find what was going on. They couldn't find. So at a certain point, when he realized they were just trying and trying, not finding, he took her from the hospital back to the place where she was and presented her to a physician. And the guy immediately said, oh, this is something. This is the disease of the bat in the cavern, etc., etc. Simply because in that area where she was, he had seen many cases like that. But the other guy, he had seen never a situation like that. So how he could think about making a blood test with these, etc., characteristics to figure out what was going on. The amount of diseases that we have in the world is just countless, right? So that's why having quite a bit of data that no one can hold in their brain in a database, in a physician with the aid of, here I wouldn't say it's one expert, it's thousands of experts, right? It can be really a game changer. So it came another winter. Why? Because, of course, as it's common in technological, I would say, fields, we see things moving on, and it's natural that we start to promise a lot of things. Right? Oh, we proved that we can have a tiny chat GPT, but it will be no problem to make the big chat GPT. But it's not always the truth, because sometimes problems that they scale really fast with the amount of data. So if one thing works with a book, when you put a library in the same program, it simply doesn't work, right? Problems, they scale really fast. So all these predictions, coupled with computational limitations, they lead to a reduction of funding, and when there is no funding, the system crashes. And then this came up with a second winter in the late 80s, early 90s. But then came the resurgence in the 90s, and this goes to present. And my feeling, I'm not an expert at all in this field, but my feeling is from now on, technologies will go up and down. This is regular. There are many studies, and they explain very well how a technology go up and down. But AI will be there forever. That's my humble opinion. So what was the game changer? Data availability. So in the 90s, and I would say in other countries, close to the end of the 90s, they start to digitalize knowledge, right? So we started to see, for example, I remember vividly, it was 1998, was the first time I had a computer with access to the internet, HTTP, and we could go to watch to see the displays in the Louvre, for example. They start to digitalize the images, so we could see all the many things in the Louvre. So they start to be available in the 90s. And one point, at this time we had digitalized information. So you see, it was way more complex than nowadays, that everything is already born digital. Most of the documents nowadays, they will never even go to the paper, right? So they are born digital, they rest digital, they are there. So this generates a lot of data sets that were essential for training and make models. So in 1997, they started this struggle between Deep Blue, or his name, Deep Blue, which is an IBM processor and computer, and Kasparov. And I think it was in 2001 that he definitively quit. He won once and then was defeated, and he quit. There was no way to win. And this event demonstrated the power of brute force computation combined with algorithms. So in the case of chess, it's really allowing calculating many possibilities and the probabilities and etc. So at the end, you have to do it fast, and it's a lot. The space is gigantic. So when they had the first Deep Blue computer, it reached the level of computation that really could defeat someone like Kasparov, which was the largest champion in chess in the world. Now, in 2010, then that was the final ingredient to create AI, which was the computational power. That came the GPUs. So in the tens, we already had a lot of data, and it came the GPU that combined data with computational power. So the GPU age started around, I would say, 2008. I was living the States at that time, and they realized, companies like NVIDIA, they realized the architecture of a GPU, which is different than the architecture of computer processor, could be used in many fields. What's the difference? In computer processor, at the time, we had 1, 2, 4 cores maximum. So most of the time, each processor had just one CPU core. Then they start to realize they could put more cores in the same CPU. And at that time, I think it was 4 maximum. But then in the GPU architecture, you have hundreds, thousands of cores. But the difference is each core cannot access as much memory as the CPU core. So for example, nowadays, one very good GPU has more than 100 cores, but 32 gigabytes of memory. And your laptop, for example, may have 32 gigabytes, but with just 10 cores. So at this point, they realized GPUs, they can be really good for some applications. And NVIDIA started to push this business of selling graphics cards without a graphic output. Can you imagine that? You pay, some of the GPUs can be as expensive as $100,000. You buy a $100,000 board, it's a video card, but it has no video output. Why? Because you don't want to do video processing. You want to do calculations inside the GPU. In the beginning, the idea was to target video gamers, the GPUs. And it's still today, video gamers are one big market for GPUs. And I remember well in this time, for example, in the field that I do computations, some of the algorithms that we have can be you can run efficiently in video cards. So there was some scientists who realized that they could run these algorithms in boxes like PlayStation. And the PlayStation was a very good deal for the processing power with respect to money. Why? Because Sony, for example, they do not want to make money in the PlayStation. They make money in the games, right? So there was some scientists making clusters of PlayStations to do computational science, to do calculations. But then there was more recently than the video games, there was a incredible change in the world that pushed GPUs really hard to develop. What was it? What do you think is today? Where are most of the GPUs doing calculations all the time? We have farms of those. In Brazil, it's interesting that Brazil created a hydroelectric, which was before China's hydroelectric, the largest in the planet. And they did in partnership with Paraguay. Because the river is a river that separates Brazil and Paraguay. Brazil had part of the energy, Paraguay had the other part of the energy. But Paraguay doesn't need energy as much as Brazil and as much as the hydroelectric would produce. And in the case of hydroelectric, the river is flowing, so energy is being produced. If you don't use, energy is being produced. So farms of these GPUs, they went where? To Paraguay. Why? Because energy was cheap. What I'm talking about? Farms and farms of GPUs processing all the time. It's not theoretical chemistry. Is what? Let's see if someone. Bitcoins, right? So probably most of these GPUs now are searching Bitcoins, right? It's a big market for GPUs. So nowadays we have computational power, we have data, we have everything. So big data, explosion of images, text, speech with YouTube. You have, right, enough fuel for doing incredibly complex models. So then it came also the algorithm innovations, and this is what we call today deep learning. So if you have computational power, you can take your data and you can process it really many times. And every time you process it, you can gain more knowledge, and so on and so forth. One example that I like to give is the following. In the past, there was this work that to de-record, let's say, audios. So, for example, you have a sentence in the judiciary, right? Everything that was spoken there has to go to paper, right? So sometimes there's someone typing, and sometimes you record what was going on, and after that, someone will degrade, will just write down everything that was spoken. Okay, so when these models came up, you could take an audio file and just use the model to compare the sound and create the text. Good. One great difference. In the past, you had to listen to what people were talking and put it on paper, right? So if the audience took 10 hours, you would at least, and of course we know it takes more than that because sometimes you stop and come back, stop, but at least 10 hours. With the digitalization of the voice, this could take as fast as seconds. This can go really fast depending on the speed of your computer. But not only that, the programs now, they can go in one direction. They can capture 90 whatever percent of the text, but they can go back again, and they can do that many times to fill up and to correct the blanks. Why? Because there are some words that someone speaks in a different way, and in the first time, the computer gets it wrong. But the person speaks again and again, and every time there's a context, and this is really important, the idea of the context that artificial intelligence is now able to capture. And as they move with the context, then the program says, oh, okay, this sound means that word. So next time it go again in that audio, it will correct everything. And so nowadays, it's almost 99.99% is captured. And in a matter of seconds, depends on the speed of the audio. So we had these convolutional neural networks, the CNNs, for example, for image recognition, and recurrent neural networks for sequential data that really came up as a result of this computational power. So you imagine that every time you take a neural network, you have neurons everywhere, layers of neurons, number of neurons per layer. Every time you add another layer, you add another neuron, these become more and more computational intensive. So if you have a lot of computational power, you can add many layers, many neurons, and make this information go back and forth, back and forth. It's like I see a neural network as a, you see all the connections. No, you have seen this picture already, all the dots with all the connections. Every time you go back and forth, you adjust the weights connecting the neurons. Every time. And you adjust. So if you can do that many times in a matter of seconds, of course your network will be perfect very quickly. You can get high precision. And then came really the game changer. This was the game changer that I want to show you. It's very, very interesting. The so-called transformer and the large that enable the large language model. So this transformer architecture, it came up in 2017 by the people, scientists working at Google, and they really revolutionized natural language processing. And this lead to the models like ChatGPT and all of that. So the transformers architecture really make the change. What is this transformer architecture? So this transformer architecture, which is also called deep learning, it's based on what they call attention mechanism, in which the text is converted in tokens, and each token is converted into a vector. So when we train ChatGPT cannot understand words. It transforms everything at the end of the day in vectors. So what you have is a bunch of vectors. And why this is interesting? Because at each layer of the network, the token is contextualized with the scope of the window via this attention mechanism. And the idea is you can amplify and reduce the signal depending on the importance of the token. So with this mechanism, you basically make artificial intelligence learn what is the context of your word. And this is really important because even for us, for human beings, this is difficult sometimes. There was a situation that happened to a Brazilian in the States that represent very well the importance of the context. So these guys, they were athletes, bikers, and they were going to the States for a competition. When they came in the customs, guy saw something, cylinder shape, etc., and he asked, "What is that?" And said, "Oh, this is a bomb." In the States, this word people even avoid to tell. They call the B word. They even avoid to speak bomb. But at this moment, I believe there were 10 policemen on the top of him, and he even spent some time in jail to explain that what really happened is, in Portuguese, the pump is bomba. And he just tried to create a new word, and he said, "Oh, this is a bomb to fill up the tire." But he didn't even have time to finish the sentence, you know? It was just a pump to fill up the tires of the bikes. But then to explain that to police, it took a couple hours, if not days. So you see how the context is important. No? Just a word outside the context can give you a lot of trouble. So what is ChatGPT, which is the tool that we are interested to use? So what is interesting is ChatGPT is not just one model. It's a package of several models, and depending on the prompt, it will use one or the in the artificial intelligence environment. But it's built on the large language model capability, and nowadays it's able to answer questions, generating text, summarizing documents, translating languages, writing codes, and analyzing image. So ChatGPT is actually a user-friendly interface. So it packs several AI models, and depending on what you demand, it will use one or another model. So it's really an environment, right, that you can use to analyze images, translate documents, so you can add one thing that I'm using quite a bit now. For example, I have many documents that I have to extract information, but it's not only extract information like making an OCR. Like in the past, you had a page and you want to extract the text, but I want to grab specific information in the document. So for example, I have a document that I won a project. And in this document, you have everything. You have the title of the project, who gave me the money, how much, etc. So I can give the paper to ChatGPT as an image, ask it to analyze. Most of the time, it does some translation because it was coded. The target, most of the documents are in English, so it will do some translation, and then it will generate the text I asked to extract. So it's a very complex environment. As I mentioned last time, one of the problems in ChatGPT is sometimes when it does not find the text I asked, what it does, it generates whatever. It has even no sense. So this is something that we have to be careful. So what GPT comes from? It comes from generative, meaning that it produces new text. And this is quite important because, as I mentioned, if each of us asks the same question to ChatGPT, most likely each of us will have a different answer. It's pre-trained, another very important point. Why? It's trained on massive data sets before deployment. So this is one of the reasons that, for example, motto-wise at the end of this talk, we will see that ChatGPT may fail terribly if you give him a paper to analyze, for example. Why? Because it's trained on data sets up to that date. So sometimes you give some new information that it had even no training about it. So this is the point. It's not being trained all the time. When you release a new version, so the train was until the, of course, they can keep collecting data and etc. to generate a new version. But that version that we are using was trained up to whatever date they released that version. And it's based in the transformer architecture. So the T is from transformer, which is the neural network architecture I mentioned, introduced in 2017, which it was a game changer in the field of artificial intelligence. So ChatGPT does not retrieve answers from a database, not like the early AI models I mentioned that it's just grabbing data in the database. It really generates, that's why it's the G, generative responses, and it uses statistics to generate this response. Okay, so how we train AI models? Two main approaches. Supervised learning, unsupervised learning. With supervised learning, you have to label data sets. So for example, you have an image and you describe the image to the machine and you do it many times. With unsupervised learning, the models, they have to discover by themselves. So they have to process the data and learn by themselves. Of course, nowadays, you have heard already that ChatGPT has been trained with all contents on the internet. It is impossible to make that using supervised learning. So in few years ago, I was developing a project, a master thesis with a guy from our Brazilian Federal Police, so it's our FBI, and his project was to write a code based on artificial intelligence to read the documents that are released every day by security agencies all over the world with possible threats. So every day, the FBI, etc., they have a conglomerate of agencies, and they release reports on possible threats. It's impossible for each of these police to read all the documents that everybody released. So what was his idea? To write a code that will read that and will red flag some of the reports. What was his problem? Good data sets. So what's a data set? It's really take the word and say, oh, this may be a threat. Take another word, this may be a threat, etc. And try to put that into context. So you see, they said that they had some data sets that they, for example, they could pay, and you see that many, like these call centers, they have many people in the room with a computer doing things. You can pay that and it can be not too expensive, but you need huge data sets. So you imagine how many people you have to do something like that, right? To generate labeled data sets. But with ChatGPT and all these new algorithms, you just will not need this labeling tool. So just to give a pictorial example, what is a supervised learning? So you have here an image. So you have this image, you tell the computer, oh, this is a mountain with a sun and it's shining, etc. And you have many examples of that. You have the, for example, the case where in the past they had a cat and dog. And you present, this is a cat, this is a dog, this is a cat, this is a dog. And then you present an image and ask the code, what is that? Oh, this is a cat. Oh, this is a dog. So that's supervised learning. With unsupervised learning, which is the case of ChatGPT, you don't have labeling. You just have algorithms that will discover the patterns in the language. And what why this can be interesting to us scientists trying to use this tool to write. So before we go into this detail, I will talk a little bit of how ChatGPT works. And it's important to mention this is it's just on the surface of the mechanisms, speak from someone that has no background in the field of making large language models. So it's just really to give you a brief overview. So as I mentioned before, large language models, they do not read words, they process what we call tokens. A token can be a word, part of a word, punctuation, and also an image representation. How you divide this token, which is a process that we call tokenization, is a secret of the model. So everybody has his own secret and it's not published, right? So, and we have a student in our lab that's making his own ChatGPT, and he was testing different sizes, token sizes, and he was seeing quite different responses depending on the size of the token. So if you say, oh, a token is 10 characters, then you have a response. Oh, a token is 3 characters, then the behavior is different. Just to give you an idea, ChatGPT 3 was trained on 500 billions of tokens. So if you think about a word, so 500 billion words is a lot, right? Just to give you an idea, I have a book that tells me I'm studying to learn French, and it says at the end I will learn 500 words. And 500 words, I'm already in B1 level, which means I can sustain a conversation. 500 words. And ChatGPT is 500 billion. This is a lot. Okay, so for example, we have a sentence. ChatGPT helps scientists write papers. So in the tokenization, you have ChatGPT helps scientists write papers and period. Using 1 token per word, which is most likely not the case in ChatGPT. But then, what is next? Each token is converted into a number in a lookup table. So you can just have you will construct these numbers, and every time the same token appears, it gets the same number. So for example, you can say that chat is this number, GPT is this number, and so on and so forth. So tokens are not full words, as I mentioned, and modern models, they use subtokens. So tokenization is the step that converts human language into numbers that the machine can understand. And in this time, it's difficult not to make an association of ChatGPT with that. Right? So the matrix was just numbers. This is what our texts look to ChatGPT, just numbers. Here is way more complex because you have numbers, letters, you have everything. But at the end of the day, it's like that. But another thing that's quite important, that after tokenization, so after converting to numbers, then each token is converted into a vector. A vector that's represented in a very high dimensional space. So you can imagine as many coordinates this vector has, the more detailed, I would say, the word will be represented, right? So at the end of the day, why we do that? Why we use vector space? And this is interesting because I think all of you have studied linear algebra in your graduation, right? So you have basic concepts of vectors, the idea of direction, components, and internal product, which is the most important to ChatGPT. So the idea is similar words, they appear close together, and different may appear further apart, right? At the end of the day, what ChatGPT does is really the internal product, the dot product. And if these words are aligned, then they are similar. If they are in opposite directions, so the idea is to use these vectorial calculations to capture the semantics of the relationship. This is the beauty of these new models. So the vector representation allows to understand the semantic relationship, context relationships, and generate coherent language. And this is quite interesting because this is why, for example, ChatGPT is so good at doing translations. When I was when it was the 2010s, China started to produce a lot of papers. It was more or less around this data that we could see more and more scientific production coming from China. And I remember very well that the first papers, they were poorly written, and you could clearly capture that someone that was not a scientist was translating the papers. Why? Because the words they used were not contextualized. So you have, for example, a word like spin of an electron. This has no translation. You cannot translate that. But probably in Chinese there is a word, when it's translated to English, it doesn't come as a spin. And when you read that, this was not someone that knows any science to have this word. It's completely different, right? So with ChatGPT, if you give a text and ask to translate, it will compare this text with texts that specialists wrote, and they can translate using words that are highly contextualized. And this is what is very nice. Right? In the past, for example, just to give you an idea, there are expressions that they are correct from the point of view of grammar, but they are not used currently, right? So there still is, you can find there that what they call corpus of a language, which is a website with texts, current texts, most of them collected from newspapers, magazines, articles, etc. And you can write the expression and ask if it's more correct or more used in this context than another. For example, things may come and go. If you have this similar expression in French, you can probably say things may go and come. And then it's, is it like that? Come and go, go and come. At the end of the day, it's the same expression, right? But how they use more. So you can go in this corpus language, you can put there, and they say, oh, come and go appears in 99% of the expressions we find these two words, and go and come is just 0.1%. And you have a context in this sense. Of course, no one will use that to write a paper. It would be just impossible. But this is what ChatGPT does. It puts your paragraph, your text, in context with texts that were written by other specialists, and this is why the translations are so good. But the point in the model is to predict the next token based on vector relationships. So this is a representation of the vector, and this is how you can understand how, for example, these coordinates of the vector, they can be really powerful. And depending on how many coordinates you can add, the word, the token will have more and more sense. So these coordinates here, this is not given by the man, right? This is just one idealization. So, for example, you take this first coordinate, when you compare all of them, you can say that this coordinate is a living being. Why? Because in the case of a cat, it's positive, a kitten is positive, a dog, and a house is negative. So this is just someone who made this association, right? But in principle, ChatGPT will do that automatically. So while doing that, after you do what they call the embedding, you can have a figure just like that. Dog is here, cat and the little cat is close together, and house is over there. You have something very similar in chemistry. What is that? You have seen already? Figure like that, where you input your data, a multidimensional data, and you split up things in groups according to vectorization, but then you give a large table of data, so you have, let's say, 20 dimensions, but at the end of the day, you can reduce that into 2 dimensions. Have you seen that already in chemistry? This is what they call principal component analysis. Have you heard about that? So, already? No one? So, principal component analysis is basically the idea, for example, of trying to find relationship between variables. So you run an experiment with many variables. Let's say you take a polymer, you take the color, the smell, etc., 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 etc. So this is a multidimensional space. After 3 dimensions, we cannot represent the figure, right? So you give this to this principal component analysis, and it tries to rotate this bunch of data that you have in a multidimensional space that you cannot visualize in order to find what is the direction where you separate most of these components. And at the end of the day, you have the idea is to reduce that to 2 dimensions so you can represent 2 dimensions where you carry out most of the variability of the data. At the end of the day, your data will be an equation with some characteristics, what we call the principal components, and we hope the two components, 1 and 2, they will give the most differentiation of this data. And sometimes you can say, you can do just like that. Oh, the component A is something that we can call living being. The component B is if a feline. The component C if as woman or something like that. Okay. So sometimes, for example, one example that I can give you for this use of principal component analysis is in the past with organic materials, they were trying to develop sensors to test wine. This was called the electronic tongue. So what was the idea? We have polymers, organic polymers, in a arrangement just like your device with contacts, measuring the resistance of the conducting polymer. But many different conducting polymers, many of those put together. And then you take what was the electronic tongue, just put in the wine, and each of these sensors will give a signal. And at the end, you process this signal, trying to separate the different types of wine. I have heard that this project was in the 2000s. Nowadays, the best sommelier is an electronic language, an electronic tone. It's no longer a human. So with these new materials, you can process, you can separate the wines with certain characteristics more efficiently than the. So this is one example of what if you could plot what ChatGPT is something like that. Just a bunch of points in a multidimensional space And each point, of course, can be related to a token. In this case, a token is a word. I like this figure because the idea is, for example, and this was something that a professor in computational science told me. When you put all this knowledge into one program, into one model, you can make correlations between things that people in the past they couldn't see. Because in practice, let's say our brains is one ball like that, right? We have knowledge, and if you could represent, this would be some area of this full knowledge. But very few, maybe I would say no one, has the entire knowledge in their brain, right? And sometimes, even by chatting with ChatGPT, you can try to make correlations between different areas of this ball of knowledge that no one thought before. Right? And this sometimes can be something that's really simple. For example, you are trying to characterize a material, and everybody do this, that, that, and that. And at a certain point, you say, why can I use vibration and acoustics to try to extract this type of information? So it goes in different areas of the knowledge, makes the dot products, and say, oh, yes, yes, you could do it. And you come up with a new experiment or a new example that no one thought before, right? So this is, I did one exam in Brazil a few years ago. I was just amazed with the technique. And this was a new technique. So the idea was to investigate the amount of fat in my liver. And I had done many tests, blood tests, etc. But the guy really wanted to go inside the liver and get a very good number. So they had, up to that exam, a CAT scan, just a CAT scan that will kind of slice the liver, etc. But every exam has some kind of limitation. For example, a CAT scan can figure out what's going on in a very part of the organ or something like that. The liver is our largest organ. So then they came up with a new idea, which was the following. You go inside the tomograph with a metal plate on the top of your liver. And it's like you put a kind of vestment that's an elastic vestment and the metal plate there. And you know the magnetic field in a tomograph, right? Sometimes people like polishing the floor with this big machine, the tomographer pull the big thing on the, so it's a huge electromagnetic field. But you go inside with that metal plate, and the field generated there is done in such a way that will make the plate vibrate. And when the plate vibrates, the waves, the mechanical waves, will propagate, and with the imagery of the tomograph, you will see what is fat and what is not fat. I was amazed at that, because this is one idea. If you thought about, if someone was telling me this idea and they came up, oh, I will put a metal. Are you crazy? A metal inside a tomographer? This will not be a good idea. We have seen people that die because they forgot to remove a ring or a collar in the tomograph. Imagine putting a metal plate. But it works. So this is one of the things that... so one point that it also created this ChatGPT and makes a big difference is the self-attention mechanism that make all the words in a sentence being read simultaneously. And then with the process, just few words will be more important, and this will build the contextual meaning. So for example, when you write a sentence that the animal didn't cross the street because it was tired, the model knows that it refers to the animal by reading the entire sentence at a time and putting it into context. So again, it's difficult not to come up with this relationship with this movie that we have seen in the past. I don't know if you remember, it was, I think it was The Visit, where they had aliens coming and they were in a glass, right? And they just kind of put some ink in this glass, and the figures were just like this. And these figures, they were actually created using Mathematica, which is one of the most known softwares with symbolic math. So after using artificial intelligence, they realized that each of these figures is just the whole story. Well, this is pretty much how ChatGPT takes the text. It just take the whole thing at a time and try to contextualize the words. So, generating an answer. How ChatGPT responds to a prompt? It analyzes all the previous tokens, calculate probabilities for the next token, and then choose the most likely one. For example, if you type in ChatGPT just that the capital of France is, it will write Paris. So it reads the tokens and calculates what is the next token. And this is why people say there's a neuroscientist, a Brazilian neuroscientist, he's very prominent right now. He's studying these chips that people will put in the brain. And he says, oh, ChatGPT is not intelligent. It's not intelligent at all. It's just calculate the next word. But what is incredible is how something that is so simple in the conception can make such interesting things. You know? So I believe it's not just simple as calculating the next token. So the questions we will try to answer is, does ChatGPT can help us to extract key information from papers, interpret figures, tables, diagrams, evaluate papers, spot errors in papers, respond to reviews, comments, and teach us how to write better papers? All of these tasks we do every day, right? Few tasks more often, others less often. But in your scientific career, you will work with that all the time. In the case of extract key information, is related, for example, to the amount of papers that we have today. And if we have to read all of them and think about all of them to extract most of the important information, this can take quite a while. So if ChatGPT can help us to just quickly figure out what's going on in the paper, to help us to separate the wheat from the shaft, those papers that we have to dig in more efficiently, that would be great. Interpret figures, tables, and diagrams. The figures, as we know, they contain a lot of information. And sometimes, if it's something that we have done before, for example, UVVs, I do UVVs all the time. Oh, so if I see these UVVs, I know this broad peak means this sharp peak means that, etc. So you look at the UVV spectrum, you know how to read. But sometimes this is not the case. They came up with some figure that you never seen before. And can ChatGPT help you to understand what this figure means? They sometimes means a lot of things. Evaluate papers in the sense going towards peer review. So get a paper to review, Can you do that? Is allowed? You are allowed to take someone's paper and put in ChatGPT? And does ChatGPT can do a good job? Do some quick evaluation. Spot papers, errors is, for example, an error can be as simple as a minus sign. From time to time, we forget in the equations to some sentence that it's really wrong, right? Our interpretation. Respond to reviewers' comments. Oh, this is a quite complex job that sometimes you have to face. Convince someone that either we are right, or one of the most problematic times is when someone asks us to do other experiments. So you have done already a bunch of things, and oh, if you could go in the synchrotron and do this, it's impossible. So how can you answer to these comments? And teach us to write papers in the sense I mentioned before. You write your text, you give to ChatGPT. ChatGPT helps you to put in a more appropriate language, using more appropriate words, and organizing your thoughts. This is quite interesting. Okay, so this is the article, free download. You can get from ResearchGate. And the idea of these three guys, the authors, they use ChatGPT, and this ChatGPT enable new Bing, which is the LLM of Microsoft, with certain prompts on papers that they wrote. So they knew what was going on, they knew what was the idea, and they run these prompts and compare the answers of ChatGPT with what they know it was on the paper. So the first prompt was to extract information from papers. So the prompt was, list the key findings in this article in detail with bullet points, with information on how authors obtained each of these findings. And they used ChatGPT 3.5. And the idea, what they realized is ChatGPT could summarize the contents of the paper very effectively, going beyond repetitions or rephrased words from the abstract and the conclusions. So if you remember well, when we give that class, giving a strategy on how to read the paper, the idea was to read the title, abstract, beginning of the conclusions, go back to introduction. So in the beginning, they thought ChatGPT could probably just grab parts of the text, conclusions, abstract, etc., and at maximum rephrase what was written by the authors. And they realized, no, it really could go a little beyond. And in a matter of seconds, they did, that's their conclusion, no? Did what a normal PhD would take hours to do. So what is the point here? If we had no ChatGPT, for example, when I was in your position, I will take the paper, I will read the paper, I will highlight, and I will write in Mendeley, as we discussed, a small paragraph with the key points, what are the applications, right? This is what a regular PhD will do, and this takes hours, right? Period. What they did, what they found is ChatGPT could give this summary in just seconds. Should you trust this summary? My suggestion is, if you see the bullet points and all of them have nothing to do with your work, you probably are safe to discard that paper. If you see one or two points that, these are interesting, maybe you should do the PhD work, read the paper, and mark. Right? So the idea is to test if it's always to not trust what ChatGPT just spits out, but of course, it is definitely an important tool to assist you, not to give the work for ChatGPT, but to help you. One suggestion that I give you, once you write your scientific text, ask ChatGPT to give answers such as, what are the key findings? What is your central research question, for example? Remember that we discussed in the past that in a paper, you should have a central research question that should, everything should orbit around it. And you can have key findings. So you write that into a paper and you may ask, what are the key findings? So would ChatGPT find your key findings or not? You'll find less. And sometimes you may even find one put into the context that you yourself didn't even realize. Oh, I discovered that and I didn't knew it. So this is an important idea. Interpreting figures and tables. We discussed with you that in figures and tables, you can pack a lot of information. And sometimes it's difficult for us to read the figures, especially when you are not used to this kind of diagrams, right? So the author, sometimes they are very creative to write some figures in such a way. For example, sometimes taking the derivative of a graph gives you extra information, very important information. But sometimes it's not easy for us to capture that, okay, the derivative will show that, etc. And so this graph of derivative means that. So it takes some interpretation. So the point was, can ChatGPT go beyond simply what was described by the authors? And why can it do that? Remember, it has the context of the massive knowledge in his database. So it can take that figure to the internal product and come up with new generated text that is beyond what's written in the paper. The conclusions was, using the prompt, tell me in detail what figure X shows and proves in this paper. They concluded that the model can summarize the author's description of the results and identify specific conclusions in the paper that are supported by the figure. So it looks like, indeed, it can just take the figure and use what was described in the text to support the figure and summarize that figure for you. But actually, they found that it can go a little beyond that. What did it do? The model was able to extract features from the image, for example, peak positions, and assign approximate numbers that are not found on the paper. So imagine you have a spectrum, and the spectra is UVVs, it has peaks. So it could really read the scale, read the peaks, and say, oh, the first absorption that the authors mentioned, this first absorption is important. So ChatGPT could grab more or less the position of that absorption and write, really creating new information that was not on the paper. So it really can, it's capable of reading graphical plots directly rather than relying on what was discussed in the paper. This gives me, and this is one point of artificial intelligence. It's evolving so fast that there are things that now you cannot do, and maybe tomorrow you already can do with ChatGPT, right? So we have a problem in the lab that we are trying to solve, that is, for example, to grab the absorption and emission spectra of polymers that are in the literature from the figures, from the images. Is this possible? Yes. But how? One by one. And we have around 200. So it's difficult, right? But this information I just put in the slide just tell me, wow, GPT may be able to do that. So just take a spectra, give to ChatGPT, tell me the position of this peaks. It can be already a great help. And actually, the project I mentioned to you with the federal police in Brazil, he started not using ChatGPT, and I naively told him, try ChatGPT, why not? Try. And at the end, he ended ChatGPT to do some tasks. So this is really, AI is evolving really fast. And so one limitation that they found was to ask a more complex text involving images. And the prompt was, please help me analyze figures and tables of this article and explain the information in each one in detail. So when they prompted that, then ChatGPT answered with a response in two parts. And this is a sign that ChatGPT replied saying, oh, this is too complex. I will divide this question in two parts. First, I'll talk about this, second, talk about that. So with figures and tables, the suggestion is demand the analysis of one figure or one table at a time, right? If you give more than that, maybe the answer will be not as good. Evaluation of research papers. This is something really interesting because the idea is you can do with papers of others and with papers of yours as well, right? And finding the strengths and the weaknesses of the papers. And for example, in project writing, in science, most of the time, we do not speak much about the risks of the projects because science is risky all the time, right? So all the time you have an idea, you put that into an experiment, the chances that this will go wrong is like 100%. It's difficult to, but in the area of engineering, they have this culture of always trying to predict the risks and from the beginning already predict what would be the solution, right? So in most of the science engineering projects that you submit for funding, there has to be a section with risk assessment. You enumerate the risks and what you will do if you find that situation. I'm writing a project right now which is science mixed with engineering because the funding agencies, they are requesting more and more that we have applied science. And I asked ChatGPT to find what would be the weaknesses. I had some in my head already, was some of them obvious, but indeed, he could give me other risks that I didn't realize, and they're clearly possible risks. So definitively, by taking what you are giving in context with the huge knowledge it has, it can provide you with very useful information. You should not, you should try to use it. So an appropriate evaluation can help authors to better present the ideas, highlight the strengths, and explain the weakness, how the weakness do not reduce the importance of the work. So ChatGPT can help you to do that. As I mentioned also in the past, there's no scientific work that is complete, right? There's always something missing. There's always something that you could have done if, but we have limited time, limited resources. But how? But ChatGPT can help you to explain why to not have done that or not have done something else will not reduce the importance of your work. And this is quite useful, especially when answering to reviews, to referee reviews. So the prompt was analyze these papers and tell me the strengths and weaknesses in detail. And the authors mentioned that the model response was impressive. The model apparently compares the manuscript with other publications and thus can generate suggestions reflecting a broader literature context. So that is the point that's quite nice in ChatGPT. It has a broader literature context that goes way beyond your head, the head of your boss, and the head of your co-authors, right? So it can really goes in this broad context and grab possible weaknesses, possible points that you can improve, and things like that. So gouging, comparing the model against human experts, one point that they realized is in the case of evaluation of research papers, the model was unable to identify specific issues pointed by the reviewers, even with guided prompts. And they concluded ChatGPT cannot fulfill the role of peer reviews, providing comments on specific issues of the paper. So what they did, they took the paper, asked ChatGPT to kind of review, then they took the reviewer reports of the paper, and they look at the issues reviewers pointed out, and they tried even to stimulate, oh, ChatGPT, you don't have any problem with that? No problem with that. So it really realized that you cannot go deep into the issues. And one point that they also realize is I think I will mention that in the next slides. But for example, what they also realize is ChatGPT. It's very easy for someone that has some knowledge of peer reviewing to identify a review that's done by ChatGPT and by a human being. And the difference most of the time is the following: ChatGPT will go just on the surface, and the human being will go into specific details and go deep into the details. And this is obvious. Why? Because that detail is what I'm expert, right? So when I found something where I'm expert, I can go into detail, each comma and each equation, etc. But sometimes only related to one issue. So my report will be essentially that issue that I'm an expert, where the paper has many other issues, right? It takes really a good reviewer to take a paper and point out issues in many different areas, right? I have this, for example, an experience with that, with theoretical and experimental papers, because you are either experienced in the theory or in the experiment, right? So sometimes we always give support to the experimentalists, and most of the times the comments on our part is, why use this basic function, something that's very simple, because we know is what the experimentalists heard about. Oh, this thing called basic function in theory, and this changes a lot, but stops there from there, right? Whereas when someone is from theory and gives the comment on our paper, most of the experiments just can say anything, and then in the theory it will go deep. Oh, why you use this method? Why was not that method? Why you didn't calculate that? Why? So they go very specific on the fields of their expertise. Now, there is one point that I should mention, and this is quite important, is that journal policies, they ask, and I put between quotes, that reviewers do not upload manuscripts in generative AI. Publishers point out the limitations of the AI tools producing nonsense, biased, and false information, as we discussed many times here. And also the fact that manuscripts may contain sensitive and proprietary information that should not be shared outside the peer review process. The point is, they say, do not use this very nice tool that will cut your work into 1/10, that will help you to produce a nice report, etc. Not use that, but they do not give a tool to do that. So a proper environment, that we have a large language model that will not share information, etc. So one of the requests of the reviewers now is that the journals, the editors, they start to build their own ChatGPT to allow access to reviewers to use these tools, because it's really a very efficient and important tool, right? And by the way, this is what's going on right now in the governments. So governments all over the world, and I see in Brazil now lots of movements in this sense. So they do not allow their employees to use ChatGPT or GPTs in their work, daily work, but they are working to construct GPTs so they can use these GPTs in their work. Right? Nowadays, it's quite often in Brazil. So as I mentioned, it's reasonably simple to identify a review comment was generated by AI or not, because they are relevant. The AI comments are relevant but broad in nature. They lack sufficient details. They do not address specific issues in the manuscript. Human experts, they tend to pay close attention to specific issues, which of course are from their knowledge. So it's very easy to, and of course, when ChatGPT writes things, usually it will, of course, do something similar, no? Just write broadly, and it needs from you, from your intelligence, to go in specific details. Spotting errors. Errors are not uncommon in scientific writing, can vary from a simple typo in one equation to wrong statements. They use ChatGPT with this prompt. I want you to read the entire article and identify the mistakes. And the authors found that ChatGPT could find some errors, but failed to recognize others. So it's still not really efficient to do everything. Despite the shortcomings, the author agreed that ChatGPT offers valuable assistance for researchers to find errors in published research. So again, it is an important tool to assist, not to do the job, right? So you may ask ChatGPT to review your text, but you always should do this revision yourself. Do not trust that ChatGPT will find all the errors. And simply, as I mentioned, the training is something really important, right? If ChatGPT was trained with some information that is in your text, came with information after the training, it will not have this information there to help you. Simply that. Respond to reviewers' comments. So the prompt was, read this article and provide a detailed rebuttal to the reviewers' comments below, using information in the article and web research if needed. What they found, the model evaded the issue raised and failed to address the criticism directly. So this is something that is also kind of common in ChatGPT. Sometimes it tries to get a tangent and goes in another direction than what you asked. Another point, which is critical in my opinion, the model response contains outdated information, which is, I just mentioned, an inherent use issue of the LLMs. So if this model was trained with information up to 2024, then that's what it will have to explain what's going on. So the outdated, in our case, that we are writing with novel facts, this is an issue. But there is one important thing that ChatGPT did, and which is quite important for us. AI organizes arguments and evidence in a progressive manner to formulate strong, neutral, and sounding rebuttal, being useful to assist researchers in preparing responses. So this was cool. And this ChatGPT does well. So sometimes you have to provide a rebuttal to a referee report and you write, but the text misses coherence and neutral language, because sometimes you are angry with the reviewer and it's not as complete, etc. So one more time, it can help you to edit your original rebuttal, organizing the arguments, and using a very neutral language. So one more time, to assist you, not do the job for you. So responding to difficult requests, they found that the reviewer's request was not fulfilled in the manuscript, but again, interesting, the model structured the response by acknowledging the limitations of the methods, explained technical difficulties, structured the response, explained the technical difficulties, and admitted the author's lack of access to more advanced instrumentation. So it helped the author to structure their response and also to admit that they cannot do that in a very polite. And when I was in the States, I learned quite different strategies of doing exactly that. One of them, which was the one I probably use most, is, oh yeah, we had thought about that for the next paper, for the next one, not for this one. We are already writing that in the next paper. So now what really ChatGPT can help us is with language editing. And why? Because large language models, they have been trained to process language in a proficient and context-relevant manner. So that's the idea. When you write your text, it will find with the vector dot products the proper context for that text, right? So it's quite different than, for example, if you ask a linguist to correct your paper, and this, we have done it before. And I remember even editors, there was even a service that editors, in my opinion, was really not fair, because, for example, you would submit a paper and they said, oh, your paper is good, it's quite nice, but it needs a revision in the text. And here we have this service, you can pay us. Okay. So sometimes we could even feel like pressed to pay the service to get the paper accepted. But with LLMs, that's what they do. They will put your text into the big context and provide you with very relevant information to correct it, right? So the idea is the LLMs, they can be powerful teachers in the sense of pointing out mistakes and improve user abilities to do scientific writing. So, for example, one of the suggestions that I really like, and I use it often, for example, to write when I need to write in French is read the text below, identify any mistakes, inconsistencies, grammar errors, odd phrases, awkward sentences, and other issues in the text. Suggest the corrections and explain each correction in detail. So the idea is not to subsidize the work to ChatGPT. Is really to ask this tool to help us to learn how to write better, right? So you write the first version and ask ChatGPT to improve it. And more than that, show me what I did, what is the mistakes, what should I learn, what kind of mistakes I'm doing, so you get better and better uh, at doing that. Okay, so with that, right on time. Well, this time I had little minutes extra. The take-home messages. So first one, waves of artificial intelligence. So artificial intelligence wasn't born in 2023 with ChatGPT. It evolved through several paradigms. In the beginning, we started with symbolic reasoning and data-driven learning. And nowadays it's data-driven learning. And current breakthroughs are a result of convergence of computational power, data, and new architectures, new algorithms. So right now, we are in this moment that I believe artificial intelligence will be there forever because we have data, big data, lots of computational power, and people are struggling creating new algorithms all the time. What is ChatGPT? So ChatGPT does not retrieve knowledge from database. It generates language statistically based on patterns learned from massive data sets, making it powerful, but still inherently probabilistic. And the point is, I highlight massive data sets because this is really the point where ChatGPT is trained, right? So you should always keep that in mind, that it's trained in scientific peer-reviewed papers, but it's also trained in journal articles, in texts that people wrote and put in the internet, in a bunch of things that you have no control over. So that's why, for example, they're coming up with AIs that they say, oh, this AI is a scientific AI trained only in articles, published articles. This is that type of AI, etc., etc. So the point is, you may have, first of all, probabilistic is always, all of them will be probabilistic. So you may have the hallucinations that we coined, people have coined already. But not only that, if you use big AIs such as ChatGPT, you cannot control the training set. You may have really crazy information coming out of it. With how ChatGPT works, I want you to fix in memory that it processes tokens, and this attention mechanism and these new algorithms that came up in 2017 was really the game changer. And the idea is use statistics to predict the next word, the next element, rather than understanding the meaning of the sentence. So, of course, with these new attention algorithms, it grabs the context by taking the entire picture in this probabilistic game. But ChatGPT, it doesn't care about words. Everything are numbers at the end of the day, right? So in scientific writing, ChatGPT is a powerful assistant. So the good capabilities is summarize, structuring. Structuring is quite nice, and improving text, but it cannot, I hope, especially for at least for the rest of my scientific life, replace critical thinking. So the critical thinking will be always on us, right? So the idea is to use these tools to assist you, not to replace you as a scientist. And that's it. References, and thank you for your attention.